Give an efficient synthesis of the following compound, again from benzene. Okay, so in this case we have, let's see, we have a nitro group. Nitro group is a meta director. We have a chlorine group. Chlorine group is not really an activator, but it is orthopara director. And we have a propyl group, and a propyl group is going to be orthopara director as well. Now let's look at the relationship between all of these groups, and all the relationships are kind of meta to each other. Okay, so if we have meta relationships to each other, that means that we need to have a deactivator on there first. All right, so here we have to think about what reaction am I going to do first. So if you do chlorination first, well, that's an orthopara director, so we can't do that. The other thing about this is this alkyl group here. So we cannot get a straight chain like this, second propyl group, so a 3 carbon or more, just like that. You actually have to do a Friedel-Crafts acylation first and then reduce that, okay, in order to do that. So I'm going to go ahead and start with that. So that way you can see what I'm talking about as well. So let me write that out. So here is 3 carbons, okay, AlCl3, and I get a ketone. Now once I have this, okay, now I know this group is a meta director, okay, because of the keto group. This is a meta director, so this is not yet a propyl group, so which means I can use this one now to do the other 2 reactions. Now which reaction do I want to do first? Now it's entirely up to me, okay, because it doesn't really matter. So I can go ahead and do the nitration first if I want to, or I can do chlorination, because in both cases I will get meta director, so or a meta substitution. So I'm going to go ahead and do the nitration first, and I want to do the nitration first because that way I will make sure that my chlorine that comes in is also going to be meta substituted. Okay, so it's kind of like a double deactivating thing, so the chlorine has to go to a meta position. So now I'll go ahead and do the nitration. So HNO3, H2SO4, so that gives me this, and on the meta position I'm going to get a nitro group. Okay, and so now I can do chlorination on this. So once I do the chlorination, it should also go to the meta position. All right, so then I'm at my 3rd group now on it, and I still have the keto group. Okay, I still have not done anything about that because I still need that meta position to be activated. Okay, and so now I have my chlorine. Now I have all the substituents that I need except for the one. Okay, and that one is of course the propyl group. So now all I have to do is I have to reduce this one. So I have 2 reductions that I can use, the Wolff-Kishner or the Clemenson. So I can use either one of those. I'll just go ahead and use Clemenson because I have a nitro group over here, so it'll be easier for me to just use the zinc and Hg and HCl. So I'll use the Clemenson, and that will give me then the product that I need, and this is it. So it's really again important in what sequence you do the reaction, so you can get the groups that you want in the location you want. All right, so you have some control.